Hi all, welcome to the next topic of Unit 1, Instruction Codes and Introduction to Computer Instructions. Coming to the contents, we are going to learn about instruction codes and what is the direct address and indirect address, and then we move on to the introduction to the computer instructions. So, instruction code. Before telling you about this, let me tell you how does a computer or a CPU of a computer executes an instruction. So as we all know that a computer executes an instruction which is given by the user, and the instruction will be a part of a program. So if you write a program which contains multiple instructions, the CPU executes each and every instruction of a program, right? So whenever a CPU has to execute an instruction, and we already know that the memory is stores both the instruction as well as the data that is required to execute the particular instructions, right? So initially the memory unit contains the instructions as well as the data. So whenever the CPU wants to execute a particular instruction of a program, that particular instruction's address is present in a register called address register. We have already learned about different types of registers in a computer. And the role of an address register in a computer is to store the address of a particular instruction or the operand. So when a particular instruction has to be executed, the address of the particular instruction which is present in the address register, so that the CPU or gets that particular instruction specified by the address which is present in the address register in the memory location. So in the memory location, in the corresponding address, the instruction is being stored. So it retrieves that address from the memory and stores it into a register called instruction register. So the instruction register stores the current instruction which is being executed by the CPU. So the instruction register contains the instruction that is being currently executed by the CPU. Okay, so each and every instruction has certain format. So that particular format is said to be called as instruction code, or we can also call it as an instruction format. So you see here, the organization of a computer is defined by its internal registers, the timing and control structure, and set of instructions that it uses. So a computer can be instructed about the specific sequence of operations it must perform. And these operations are specified by the user by means of a program, right? So what is a program? Program is nothing but a set of instructions. And what does this set of instructions specify? They specify what is the operation that has to be done, and what are the operands, and they also specify the sequence in which the instructions execution has to occur. So an instruction is a binary code that specifies a sequence of micro operations for the computer. So the computer generally, how does the instruction gets executed is with the help of an instruction cycle. This is the instruction cycle will tell you about the step-by-step execution of an instruction. So initially the computer reads each instruction from the memory, and the control determines the binary code of the particular instruction. So based on the binary code, it identifies what is the operation that has to be performed and what are the operands, and then it proceeds with the execution. So this all this together is said to be called as an instruction cycle. The complete execution of instructions is done by means of an instruction cycle. So the same cycle repeats for each and every instruction that is present in your program. So as I already told you, the instruction register contains the instruction that is being currently executed by the CPU. So each and every instruction present in the program has a certain format that is said to be called as an instruction code or instruction format. So the instruction code is basically divided into two parts. One is the opcode, or we can also call it as an opcode, or operation, and address part. So it mainly contains two parts, opcode and address part. So what is an opcode? Opcode is nothing but we call it as an operation code or an opcode. The operation code of an instruction is a group of bits. As we know, the instruction is in the form of groups of bits. Whatever data or whatever instructions and data that is being stored in the computer, everything is in the form of bits, zeros and ones, right? So the opcode of an instruction is a group of bits that define the operation. It can be addition, subtraction, multiplication. What is that particular instruction has to perform? What type of an operation it has to perform? That is defined by an opcode part. And coming this operation must be performed on the some data stored in the registers or in the memory. So whatever registers or memory contains the data, on that particular data the particular operation has to be performed, that is defined by the particular instruction. The second part is an address part. So the address part specifies the registers or the locations in the memory to use for that operation. So the operand part, so it has to perform an operation, but where are the operands? The operands are stored at the address part. So address part specify the address of the operands on which an operation has to be performed. So overall it is divided into opcode and address. This is called instruction code. So apart from the opcode, so here if you see, the instruction code is a group of bits that instructs the computer to perform a specific operation. So the instructions of a program along with the data are stored in the memory, and the CPU reads the next instruction from the memory and it places it in the instruction register. So apart from the opcode and an operand, there is also one more bit called as a mode bit, which is present in the instruction format. So bit I, we call it as bit I or a mode bit, and it specifies the addressing mode. So addressing mode is of, it can be either I bit can be either 0 or 1. If it is a 0, it means that it is a direct addressing. If it is a 1, it means that it is indirect addressing. So what do you mean by direct addressing and what do you mean by indirect addressing? Let us see. So before seeing the direct and indirect addressing, so this is a format of your instruction format or instruction code. So it contains three parts: the mode bit, the opcode and the address part. So the mode bit specifies based on the mode bit I, it can be either 0 or 1. If it is a 0, it means it is a direct addressing. If it is 1, it means indirect addressing. I'll tell you in the next slide about what is this direct and indirect addressing. And next part is opcode part. So opcode is a 3-bit code. If you see here, the bits of this particular instruction starts from 0 to 15. So the instruction which is stored in the instruction register is a 16-bit format. It is of size 16 bits, whereas the bits 0 to 11 identifies the address part. 12 to 14, the 3 bits, 12, 13, 14, 3 bits identifies the opcode part, and the last bit identifies the mode bit. So the opcode specifies the operation that has to be performed, and the address part specifies the address of the operands, right? So next, what do you mean by direct address and indirect addressing? So if you look at this example, this is an example of a direct address. So consider this is a memory unit which contains the address of the memory. So at an address location 22, the instruction has been stored in the memory. And if you see this format of the instruction, it contains 3-bit, mode bit, the opcode and a address. So it means that the opcode is specifying that we have to perform, the CPU has to execute an add operation, add. So what is this address part? It contains 457. So what does it means? It specifies the address of the operand. And whenever this mode bit I is equal to 0, it means it is a direct address. Direct address means that whatever address is specified in the address part of the instruction, If you go and refer that particular address of the memory, you can find the actual operand on which an operation has to be performed. Okay, so it has to perform an addition operation. One operand has already been stored in the accumulator. The other operand is specified by an address. And since I is equal to 0, since it is a direct address, if you directly go to that particular location of the memory, it contains an actual operand. So the contents of the accumulator and the content the particular operand which is stored in 457 is given as an input to an ALU to perform an addition operation. So this is the direct address. So here directly whatever is there in the address part, that is a direct address where you can get the actual operand. So coming to the indirect address, so if the mode bit I is equal to 1, it means it is an indirect address. And the address part contains 300. So which means that if you go to that particular 300 location of the memory, you can find the actual address of the actual operand. So 1350 is not the actual operand. This is an address, actual address where your operand is stored in the memory. So if you go to this 1350 location, you can find the actual operand. So that is the reason this is not a direct address. This is indirect address, which means the address of the actual operand is will be stored in this particular location of the memory. So the operand which is at 1350 is added with the contents of the accumulator to get the actual result of an addition operation. So this is the difference between direct and indirect address. So that is what is explained here. Next we move on to the next topic, introduction to computer instructions. So a computer performs the tasks based on certain instructions provided to it. So the instructions provided to a computer are divided into different fields or groups where each field provides some specific information. And the contents of the fields are written in a binary language. So as we already know, the instruction register contains an instructions which is of size 16 bits, right? And this particular instruction has three fields. As we already know, it contains an opcode field, address field, and a mode bit. And opcode field specifies what operation has to be performed, whether it is an addition or a subtraction or a multiplication, whatever type of operation the instruction has to be executed. And address field indicates the memory location or the address of the operands. And the mode bit indicates whether the memory address of the operand is a direct address or an indirect address, right? So this is what an instruction is. So in the previously when we are talking about instruction code, as I already told you, the instruction that has to be executed is present in the instruction register, which has a certain format, and the format contains mainly three parts: opcode, address, and mode bit, right? So when it comes to an opcode part, the opcode, it is a 3-bit, right? If you see the diagram here, the opcode is 3 bits, 12 to 14. So whenever the control unit, what it does is it takes this particular 3-bit opcode and it is given as an input to a decoder, so that the decoder decodes this particular binary opcode and find out what is the type of an operation that it has to be performed. Okay, it is a 3-bit opcode. So based on the decoder output, we are going to identify, and not only based on the decoder output, as well as based on the I bit and decoder, this 12 to 15 are given as an input to a decoder. Based on that, the decoder generates 7 outputs starting from D0 to D7. Okay, starting from D0 to D7. So, so the decoder So the decoder output starts from 000 to so on 111, starting from D naught to D7. So 000 D naught, 001, 010, 011, 100, 101, 110 and 111. So D naught to D7 gives 7 outputs. Okay. So each and every output specifies one particular operation. So based on the decoder output, the instructions are classified, the computer instructions are classified into three types. So they are basically based on the decoder outputs, which gives D0 to D7. The computer instructions are classified into three types. They are memory reference instructions, register reference instructions, and input output instructions. And each instruction format is a 16-bit format. So if you look at this, if the opcode, the decoder output is from 000 to 110, which means 000, 001, 010, 011, 110 and 100, 101, 110. So till decoder output D0 to D6, that type of instructions are said to be called as memory reference instruction, irrespective of the I bit, whether it is a 0 or 1. For both the cases, they are memory reference instructions. And whenever the opcode is, the decoder output is a triple one, 111, and whenever the I bit is 0, the mode bit is 0 and opcode part contains 111, then the particular instruction is said to be called as register reference instructions. Okay. Next, coming to the opcode, next one, if the opcode is 111, opcode part, and I bit is 1. So if you look at the difference between these two, both the opcodes are 111, 111, but I bit differs. So in the case of register reference, the I bit is 0. In case of memory input output instructions, the I bit, the 15th bit is 1. So whenever the opcode is 111 and I bit is 1, it means the instruction is an input output instructions. So based on this, we are going to classify the computer instructions into three types: memory reference instructions, register reference instructions, and input output instructions. So based on the decoder output, when the opcode and I bit is given as an input output to a decoder, opcode is given as a input to a decoder, it gives 7 outputs starting from D0 to D7. So whenever your decoder output lies between 000 to 110, from 000 to 110, irrespective of an I bit, whether it is a 0 or 1, the instructions are said to be called as memory reference instructions. If the opcode of the particular instruction is 111 and I bit is 0, the instruction is said to be called as a register reference instruction. And whenever the opcode bit is 111 and an I bit is 1, it means the instruction is an input output instruction. We'll know in detail about what are these instructions in the later topics, but their computer instructions are basically classified into these three types. Okay, that what is explained here. If the three opcode bits in positions 12 to 14 are not equal to 111, which means it lies between 000 to 110, the instruction is a memory reference instruction. Similarly, if the three opcode bits is 111, the control then inspects the bit in position 15, that is I bit. If it is a 0, then the instruction is a register reference instruction. If the I bit is 1 and opcode is 111, the instruction is an input output instructions. So all these instructions, they use a 16-bit format to specify an operation. Thank you.